So in this video, I'm going to show you the solutions to the arithmetic reasoning subtest of the 7th practice test on my website. This video is not going to be available on YouTube to the general public. Since you registered for a premium account, only you will have access to this. Okay. That said, let's get started with the video. Question 1 says 3 consecutive odd numbers have a sum of 21. What are the 3 numbers? So to do this problem, there's actually 2 approaches you can take. You can actually do an algebraic approach as well as just plug and chug. For example, if you were to just plug and chug, you would come to all the answer choices and say 1 plus 3 plus 5. Well, 5 plus 3 is 8 plus 1 is 9. So although these are consecutive odd numbers, they do not add up to 21, which is the criteria in the question. So we know that's not a correct answer choice. 9 plus 11 is 20, plus 7 is 27. So these add up to 27, not 21. 3, 5, and 7. 5 plus 7, 7, 8, 9, 10, 11, 12. Plus 3 is 15. So you know that doesn't meet the criteria. 7 plus 9 is 16, plus 5 is 21, and these are consecutive odd numbers, as you can see, 5, 7, and 9. So this meets the criteria, and therefore it's the correct answer choice. Now, if you have an algebraic mind, you can set this problem up like this. Let x be the first consecutive odd number. Let x plus 2. Let me start over. If we let x be the first consecutive odd number, that means x plus 2 is going to be the next odd number, and x plus 4 is going to be the third odd number. Because if you think about it, if you let x equals 1, 1 plus 2 will get you 3, and 1 plus 4 will get you 5. 1, 3, and 5 are consecutive odd numbers. Now that said, we can use this algebraically to answer this question. X plus 2 plus x plus 4 equals 21. This says the sum of 3 consecutive odd numbers equals 21. Now all we have to do is combine like terms. X's are like terms in this case. X, so that's 3x. And 2 and 4 are like terms as well. So that's going to be 6 equals 21. Now we're solving for x, so we're going to subtract 6 from both sides. This crosses out. We're left with 3x equals 21 minus 6 is going to be, let's think about that. 21 minus 1 would get you 20, minus 5 additional ones would be 15. So this would be 15. X equals 15 divided by 3. You divide both sides by 3 to get rid of that. Or x equals 5. So we know x equals 5. Therefore, x plus 2. Again, x is 5, so 5 plus 2 is 7. And again, x is 5 plus 4 is 9. 5, 7, and 9. And as you can see, those are consecutive odd numbers. So either way, to be perfectly honest with you, this is how I solve this problem, especially if I'm in a rush. I tend to make mistakes when I work with algebra, and sometimes I don't set it up right the first time. So either of these methods would work. Personally, I prefer using the answer choices that are given and just moving on to the next question. But that said, I showed you both methods in case some people are more comfortable with the algebra. Okay, let's go ahead and move on to number 2. And while I'm waiting for that page to load, I do want to mention that this practice test is fairly challenging. You may notice that the first and second practice test on my website, which are the free ones, are pretty straightforward and easy. Once you get into practice test 3, 4, 5, 6, 7, 8, and 9, I start throwing some questions at you that require you to think. So if you make your way through all the practice tests on my website and you understand my explanations in these videos, you should do perfectly fine on the ASVAB. So number 2 says, what is the average speed in miles per hour of a car that travels 956.4 miles in 15.9 hours? Okay? So in this case, we have to know that we have all the elements of the distance formula. That is, we have distance right here, 956.4 miles. We have time right here. So this is distance. This is our time in hours. And we're being asked to find the speed, which is the rate. So to set this one up, I'm going to go ahead and drop down the distance formula. And I'm going to plug those things in accordingly. Again, this is 956.4 equals R. We're trying to figure out what R is, times 15.9. Of course, since we're trying to figure out what R is, we're just solving for R. So that's going to prompt us to divide both sides by 15.9. This crosses out, and we're left with R equals 956.4 divided by 15.9. Now, this is where things get tricky. Again, you can always regard fractions as long division. This is 954.4 over 15.9 can also be read as 956.4 divided by 15.9, which looks like this. And in order to figure out what this fraction reduces to, this is in fact how we have to set up the problem. Now, as I've mentioned in several of my videos, you can do long division with decimals as long as that decimal is not outside this division bracket. Okay? In this case, however, we can see that 15.9 has a decimal outside this division bracket. So what that's going to prompt us to do is to shift this decimal place one time to make 15.9 159. And what we do outside the division bracket, we have to do a corresponding number of times inside the division bracket. So in reality, I'm doing 9,564 divided by 159. Okay? So let me go ahead and rewrite that, because I'm going to need some room to work on that one. And again, that's going to be 159 and then 9,564. Okay? Now, this is where things get tricky, and you have to actually use the answer choices that are given to help yourself zero in on the correct answer. Okay? Because now you're asking yourself, how many times does 159 go into this 9,564? Well, if you take a look, this one starts with a 5, this starts with the 7, this starts with the 6, this starts with the 6. So you kind of want to use your choices to zero in on this. There are two 6s, so I'm going to say 159 goes into this 956 at least 6 times. So off to the side, I'm going to do 159 times 6. Okay, 9 times 6 is 54. And you got to carry your 5. 6 times 5 is 30, plus 5 is 35. Carry the 3. 6 times 1 is 6 times 1 is 6, plus 3 is 9. So as you can see, 6 gets you very close to 956. It actually gets you 954. So that said, I know that this is going to be very close to 60 and not 64. So I'm going to actually do this again, because the answer choices have helped me become very good at determining what this is going to be. And I'm going to take it one step further now that I know 6 is the first digit in this one. And instead of doing how many times does 159 go under 956, I'm going to say 159 times 60 will get me very close to 9,564. And if I can say that definitively, then I'll have answered this one without having to do too much long division. Again, later in this video, there are going to be problems in which I do long division, and that long division is going to be straightforward. But the ASVAB is really a test of common sense. You set up the problem, you set up the long division, now use the information given, namely the answer choices, to help you work efficiently on this. Because truthfully, some people would be like this: 159 times 58, 159 times 59. They would do that and cover a whole piece of scrap paper and work, when these answer choices narrow the scope of possibilities. So use the answer choices to help guide your work. Again, that's going to be the difference between a 50 and a 90 on the ASVAB. Someone who scores a 90 zeroes in on answer choices, whereas someone who scores a 50 wastes a lot of time guessing and checking. The answer choices are there. Use them. So let's get back to this. 9 times 0 is 0. 5 times 0 is 0. 1 times 0 is 0. Add 0 since we're starting this number. 6 times 9 is 54. Carry the 5. 6 times 5 is 30, plus 5 is 35. Carry the 3. 6 times 1 is 6, plus 3 is 9. Let's add. We can see 0 plus 0 is 0. 0 plus 4 is 4. 0 plus 5 is 5. 9 plus nothing is nothing. So this gets you 9,540. And as you can see, this was 60 that got us there. There's going to be some remainder because this didn't go into it evenly. Let's see what we missed. 4 minus 0 is 4. 6 minus 4 is 2. 5 minus 5 is 0. 9 minus 9 is 0. So this gave us a remainder of 24. I can tack on a 0 here and keep working this out. 159 goes into 240 one time. 159 times 1 is 159. And I can keep working. But that said, I've already zeroed in on the right answer choice just by using the answer choices to guide my work. So I did very little long division. To do this one, I had to think logically and not arithmetically. Okay, so let's move on to the next one. And that one is a challenging problem because not a lot of people recognize that the answer choices can guide them in the right direction. All right, number 3 says, your friend went on a diet and goes from 125 pounds to 110 pounds. How much of her weight did she lose? So, and you can see the answers are given in terms of percentages. Whenever you're dealing with percent increases or percent decreases, you have to understand that you work them out the same way. And I like to call them this. O stands for the original, and P are, N stands for the new weight, or new whatever. So O minus new over O will give you the percentage of weight that she lost. How much did she weigh originally? 125 pounds. What's her new weight? 110 pounds. What was her weight originally? 125 pounds. Again, O refers to her original weight. N refers to her new weight. And from there, we can go ahead and figure this out. It's set up for us. 125 minus 110 is 15 over 125. Now we have to reduce, and let me go ahead and do that over here. This is 15 over 125. We should recognize right away that 5 can go into 15 and 25. Typically when something ends in a 5 or a 0, it is divisible by 5, and you can reduce it as such. 15 divided by 5 is 3. 125 divided by 5, I can't do in my head, but we can do the long division very easily. 5 goes into 12 2 times without going over. 5 times 2 is 10. 12 minus 10 is 2. Drop down this 5. 5 goes into 25 5 times without going over. 5 times 5 is 25. So we can see there's no remainder. So this is the same as 3 over 25. And like in the last problem, you have to regard this fraction as long division. Namely, you have to read it as 3 divided by 25. Okay, and I promise this one is much easier than the last one. Now we're asking ourselves, how many times does 25 go into 3 without going over? 3 is too small, so I have to add a 0. When I add that 0, I have to add a decimal place right there. How many times does 25 go into 30 without going over? 1. 25 times 1 is 25. 30 minus 25 is 5. Again, we drop down an imaginary 0. Now the question is, how many times does 25 go into 50? That's 2 times. 2 times 25 is 50. So we can see there's no remainder. 0.12 is the same as 12%. Okay, which is that answer choice right there. So that's that one. Let's go ahead and move on to number 4. And you'll find on the ASVAB that some problems the math's going to work out nice and cleanly, and other problems you're going to be in the trenches relying on the answer choices that were given, to figure it out. So be prepared to use the answer choices to guide your work, especially when things start getting very hairy. Number 4 says a class of 25 students took a science test. 10 students had an average score of 80. The other students had an average score of 60. What is the average score of the whole class? Okay, so this is a twist on finding averages. In general, the average is the sum of all the observations divided by how many observations there are. Well, we know there's a class of 25, so we know there's going to be a total of 25 observations, or test scores in this case. And we know we're trying to find the average. So what we need to figure out how to do is come up with a sum, given that given the fact that 10 students had an average score of 80, and the other students, 25 minus 10 is 15, had an average score of 60. And this, it turns out, is a weighted average. We can still use the average formula, but we have to set it up like this. I'm going to get rid of this line because I need some space to work. Again, we're trying to figure out what the average is, so that's what we're trying to solve for. 10 students had an average score of 80. Okay, 15 students had an average score of 60. And in total, we know there are 25 students. If I had to write this out, that would look like this. 80 plus 80 plus 80. Again, that would be 10 times. And then that would be 60 plus 60. That would be 15 times all over 25. And this would give us our average. Instead of writing this out, which would take a whole piece of paper just to do, we're actually using multiplication to represent these this addition. Again, 10 students scored 80, 15 students scored 60. So we can group them up like this using multiplication instead of addition. It's the same thing. This is just written out. This is condensed. So the math turns out to be pretty easy on this one. 10 times 80 is 800. And 15 times 60 I can't do in my head, so let's go ahead and work that out off to the side. 5 times 0 is 0. 5 times 6 is 30. Add a 0 since we're starting this number. 1 times 0 is 0. 6 times 1 is 6. 300 plus 600 is 900. So we can see that this is going to be 800 plus 900 over 25. 8 plus 9 is 17. Therefore, 800 plus 900 is 1700. And again, that's all over 25. And again, we're forced to use the fact that fractions are equivalent to long division to work this one out. 1700 divided by 25. Let me go ahead and see what we can do to make this one easier, because I don't like working with big numbers, and I'm sure you don't. So what I want to do is see how I can reduce this one to make the math easier. This ends in 5, so I know it's divisible by 5. This ends in 0, so I know it's going to be divisible by 5. So before I even get started, I'm going to work on reducing this. And I'm going to do the bottom first. 25 divided by 5 is 5. 1700 divided by 5. And again, this is easy to do. Anything divisible by 5 is easy to do with long division. 5 goes into 17 3 times without going over. 5 times 3 is 15. 17 minus 15 is 2. Drop down this 0, drop down this 0. 5 goes into 20 4 times. 5 goes into 200 40 times. 5 times 40 is 200. So we can reduce that. This reduces to 340 divided by 5. Again, division with 5 is much easier than division with 25. So let's go ahead and keep working this out. And I need some space. So I'm going to go ahead and get rid of this. I put a comment there. Sorry about that. Let me see if I can get rid of that. I can't. So I'm just going to leave it. Now we're doing 340 divided by 5. Now the question is, how many times does 5 go into 3? It doesn't. It's too small. How many times does 5 go into 34? 6 times 5 times 6 is 30. Subtract. 34 minus 30 is 4. Drop down this 0. 5 goes into 40 8 times without going over. 5 times 8 is 40, so there's no remainder. So we can see this reduces to 68, which is right there. Again, if you can reduce things to be divisible by 3 and 5 and 2, like I did here, instead of doing 1700 divided by 25 like this, which, I'm not familiar with these numbers, so this would take me a while to do. I reduced top and bottom by a factor of 5 to get 340 over 5, and then the math became very, very easy. So that was that one. Let's go ahead and move on to the next question. Again, just a twist on an average question. And if you're doing well in the ASVAB, you're going to see that twist. All right, number 5 says, at 5 a.m., 2 cars which started from the same exact point traveled in opposite directions at 40 and 50 miles respectively. When will they be 450 miles apart? So they started at these 2 points. One went this way. One went this way. This one was going at 40 miles per hour. Let's say this one was going at 50 miles per hour. And we want to know how long it will take them to be 450 miles apart. Now, instead of thinking about this as 2 cars traveling in opposite directions, we can see that this is going to form a straight line. So why don't we regard this as 1 car going the same 450 miles, albeit at a combined rate of 40 plus 50, or 90 miles per hour. Again, these cars are traveling in opposite directions, so we can think of them as 1 car going 90 miles per hour for 450 miles. Again, we have to recognize right off the bat that we're dealing with the distance formula, namely distance equals rate times time. So instead of doing the problem this way, I'm just going to set it up like this. Distance is given, it's 450 miles. Time is what we're trying to figure out, and the rate in this case is going to be the rate of car 1 plus the rate of car 2, or 90 miles per hour. Again, that's times time. So again, we're solving for t, so we're going to divide both sides by t. This crosses out, we're left with t equals 450 over 90. Cross out these zeros. T equals 45 over 9. 45 divided by 9 is going to be 5. So in other words, it took these cars traveling for 5 hours in opposite directions to reach 450 miles apart. Since we started at 5 a.m., we have to add 5 hours to that. 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. So at 10 a.m., they will be 450 miles apart. So that's that one. And again, I have a whole video on distance, rate, and time problems on my YouTube channel. So if you struggled with that explanation, understanding that explanation, go ahead and watch that video. That one's up there for free. Alright, number 6 says, on a map that has a scale of 1 inch equals 25 miles, the distance between two cities is 3.2 inches. What is the actual distance between the two cities? So this is a problem we're going to solve using proportions. 1 inch represents 25 miles. We want to figure out how many miles 3.2 inches represents. And again, as you can see, we have inches on top and miles on the bottom. And 25 miles, x number of miles, 1 inch, 3.2 inches. We go ahead and solve this one by cross multiplying. That is, we do 1 times x. 1 times anything is just itself, so 1 times x is just x. Again, 1 times 7 would be 7, for example. 1 times a million would be a million. And then we do 3.2 times 25. So as we can see, x is going to be 3.2 times 25. I can't do that one in my head, so I'm going to have to work it off to the side here. And I got 25 times 3.2. We're multiplying a whole number by a decimal. The trick to doing this is to make the decimal a whole number 2 by shifting its decimal place 1 time in this case. So in reality, I'm doing 25 times 32, albeit with 1 decimal to shift back into the left at the end of this problem. So again, I took the decimal away here. I'm going to add the decimal back here. 5 times 2 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5, add a 0 since we're starting this number. 5 times 3 is 15, carry the 1. 2 times 3 is 6, plus 1 is 7. Let's add 0 plus 0 is 0. 5 plus 5 is 10, carry the 1. 7 plus 1 is 8, shift our 1 decimal back in. So we can see that 3.2 times 25 is the equivalent of 80 miles, which is right there. So again, we solved this one using a proportion, and that was that. So let's go ahead and move on to the next one. And if you think these problems are easy, even someone who's college educated would struggle with these problems, simply due to the fact that they test your ability to work out what are really simple problems by hand. Again, it's arithmetic reasoning. A lot of people have not done arithmetic in a very long time. But that said, if you study enough, you should be able to pick this back up pretty easily. Number 7 says determine the probability of selecting a black card or 6 from a deck of 52 cards. So as far as black cards go, decks of cards are split in half. Half the cards are black, half the cards are red. So in other words, if we do 52 by 2 divided by 2, we'll figure out how many of the cards are black. 2 goes into 5. 2 times without going over. 2 times 2 is 4. 5 minus 4 is 1. Drop down this 2. 2 goes into 12. 6 times without going over. 2 times 6 is 12. So there's no remainder. So I know that 26 out of the 52 cards are black. So I know if I were to pick a card at random, I'd have a 50% shot, or 26 over 52% shot of picking one. And this one says or a 6. Okay? Now, in each deck of cards, each number is there 4 times. So there's a 6 of diamonds. There's a 6 of clubs. There's a 6 of spades. You got clubs, diamonds, spades, and hearts. And again, 2 of these are black and 2 of these are red. Okay? So, we know that we've already included 2 of the black ones in this 26. Okay? So in other words, we can only add 2 of these because, again, the black ones we included over here. So these were already included in our count. Of these 26 cards in there, 2 of the 6 blacks are going to be in there. So we know that the odds of picking a 6 that is not black is going to be 2 out of 52. Okay? So in other words, we have to add these fractions now. To add fractions, you just ensure that the denominators or these bases are the same. And then you just add straight across with the numerators. 26 plus 2 is 28 over 52. So in other words, the odds of picking a black card, which is 1/2, or a 6, which is 2 out of 52, in light of the fact that 2 of the black cards were contained in here. 2 of the black 6s were contained in this number, is 28 out of 52. This one's not easy to see, but both 52 and 28 are divisible by 4. 28 divided by 4 is 7. 52 divided by 4. 4 goes into 5 one time without going over. 4 times 1 is 4. Subtract 5 minus 4 is 1. Drop down this 2. 4 goes into 12. 3 times. 4 times 3 is 12, so there's no remainder. So 52 divided by 4 is 13. So the odds of this occurring is 7 over 13. Again, you really didn't need any knowledge of probability to solve this one. Again, your odds are half of picking a black card and 2 out of 52 of picking a red card, since 2 of the black cards would be picked in this one. So that was that one. A little bit tricky, but not too difficult. All right. Number 8 says, to empty their swimming pool, the Johnsons decided to use its drain in a pump. If it takes 15 hours for a pool to empty using the drain alone and 7 hours for the pool to empty using the pump alone, how long will it take for the pool to empty using both the drain and pump? This problem has plagued me for every standardized test that I've taken, including the graduate record exam. This is called a combined work problem, and you have to get comfortable setting these up to be successful on them. Once you see how to set it up, it's easy to do, but that said, these can be difficult to set up, and there's multiple ways to set these problems up. Again, we're told the pool, the drain takes 15 hours to drain the pool. So that means every hour, which I'm going to call 1 out of 15, it can empty 1/15 of the pool. Okay? The pump, on the other hand, can empty 1/7 of the pool every hour, which I'm going to call 1/7. We want to figure out how much of the pool, how long it will take both of these to empty the pool working together. Well, together implies addition, and we know this is going to add to 1. All fractions add to 1. And the variable we're missing is how long will it take them to empty the pool working together. So I'm going to throw this variable time up here. This says the pump, which can do 1/15 of the pool every hour, plus the drain, which can do 1/15 of the pool every hour, plus the pump, which can do 1/7 of the pool every hour, can empty one pool at a combined rate in this amount of time. Okay, that's what this formula says. And the way I like to do this one is to actually take this t and multiply it by this 1 and just set it up like this. T over 15 plus t over 7 equals 1. I just took this t and multiplied it by 1. Okay? Again, you can put t over 1. Anything divided by 1 is itself. Anything multiplied by itself is itself. 1 times t is t. 15 times 1 is 1. So I just simply put that t up there to make the problem a little bit neater. So now this is a simple fraction problem. We got to find a common denominator over which we can put 15 and 7. The easiest way to figure that out is to do 15 times 7. Okay. 15 times 7, 5 times 7 is 35, carry the 3. 7 times 1 is 7, plus 3 is 10. So I know this common denominator is going to be 105. Again, this is going to equal 1. 15 goes into 105 7 times, and again we still have t there. 7 goes into 105 15 times, and we still have our t there. Now we can go ahead and add these fractions. 7 plus 15, well, 7 plus 5 would be 20. Add to that, that's going to be 22t over 105 equals 1. And again, we're solving for t. So what you want to do is multiply by the inverse, 105, 22, and what you do to one side, you do to the other, 105, 22. This crosses 105 out there and 22 there, and you're left with t equals 105 divided by 22. Okay? Now, again, we're running into one of those scenarios where this math isn't obvious to do right away. But again, we have these answer choices that are going to help us. 2, 3, 4, and 4. I always like to pick the one that's there the most. So again, we're treating this as long division, namely 105 divided by 22. And I'm going to say 22 is going to go into 105 4 times. Again, 25 times 4 is 100. Therefore, I know 22 times 4 is going to get me close to 105. So 22 times 4. 2 times 4 is 8. 2 times 4 is 8. So this gets me 88. If I were to add 22 again, it would go over 105. So 22 goes into 105 4 times without going over. 22 times 4 is 88. We're going to subtract, so that eliminates those as answer choices. Now we just have to solve it one more decimal place and we're done. Okay? 5 minus 8 we can't do. 0 minus 8 we can't do. We have to borrow. This becomes 0. This becomes 10. I can do 10 minus 8, but I still have this 5 minus 8 there. I have to make this a 9 and this a 15. 15 minus 8, that's going to be 7. And 9 minus 8 is 1. Okay? How many times does 22 go into 17? It doesn't. To add a 0 there. When I add that 0, I have to bring that decimal up there. And now the question is, how many times does 22 go into 170? Well, we just saw that 22 times 4 only got us 88. So we have to decide between 4 and 7. 22 times 7, logically speaking, is going to get us closer to 170 than 22 times 4. But to prove it, let's work it out. 7 times 2 is 14. Okay, the 1, 7 times 2 is 14. Plus 1 is 15, so this gets us 154. We can see there's going to be a remainder, but as I said, 22 times 7 gets us 154. So we know that this answer choice is going to be 4.7 with a remainder. And that's how you do that one. Again, this is how you set up combined work problems. You figure out how much they can do per hour, 1/15 of the pool per hour, 1/7 of the pool per hour. You add a variable time to do one pool together, and you get your answer. Again, try to understand what I did there. If you see a combined rate problem, these are the steps you have to take to set it up. Okay, finally a normal problem. Number 9 says Lieutenant Jones gets paid $5.25 an hour for regular hours he works and $6 an hour for any overtime he works. All hours over 40 in a week are considered overtime. If Lieutenant Jones works 40 hours this week, how much did he make? So we know 40 is going to be paid at a rate of $5.25 an hour. And we know those 4 additional overtime hours are going to be paid at a rate of $6 an hour. 6 times 4 is 24. So we know his overtime pay is $24. That said, we're given this multiplication with a whole number and a decimal. So what we have to do, as I've shown you already in this video, is to shift this decimal 1 2 times and add those decimal places back in at the end. So in reality, I'm doing 525 times 40, albeit with 2 decimals to shift back in at the end. 5 times 0 is 0, 2 times 0 is 0, 5 times 0 is 0. Add a 0 since we're starting this number. 5 times 4 is 20, carry the 2. 4 times 2 is 8, plus 2 is 10. Carry the 1, 5 times 4 is 20, plus 1 is 21. Let's add. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0. 1 plus nothing is just 1. 2 plus nothing is 2. Shift our 2 decimals in. 1, 2. We can see that this is going to be 210. So in other words, he earned $210 at his regular rate of pay and $24 at his overtime for his overtime. So let's combine those. 210 plus 24. 4 plus 0 is 4. 2 plus 1 is 3. 2 plus nothing is 2. So we can see that this one is going to be 234. All right, number 10. And again, these problems are slightly more challenging than anything you've seen so far. I always throw a little twist in these problems just to make them more difficult. Again, if you've done practice tests 1 through 6, I want to add another level of your ability to think your way through these problems. to those. So again, think of practice test 1 through 4 as a foundation. And then I have 5, 6. I know that says there's only 9 practice tests on the website. There's actually 12, given how many courses I have. So think of 1 through 4 practice tests as a base, a foundation. 5, 6, and the other random ones I have on the website as taking an advanced step, and then 7 through 9 as, icing on the cake. So let's go ahead and work out number 10 now that I've mixed all those metaphors together. Number 10 says, in an introductory psychology class of 36, 4/9 of the students are boys. If 2 girls and 4 boys drop the class during the first week, what percentage of the class would be girls? So instead of just asking you what percentage of the class is girls right away, we throw this twist in there of them dropping, and we never tell you how many there are. Instead, we give you a fraction. So there's 36 in the class. To find out how many are boys, we multiply this by 4/9. And again, you can pretend there's a 1 there. And when you do multiplication with fractions, you just multiply straight across. But before I do that, I want to simplify this so it's very easy to do. More specifically, I'm going to reduce this. 9 goes into 9 1 time. 9 goes into 36 4 times. So this simply becomes 4 times 4 over 1 times 1, or 16 over 1. Anything divided by 1 is itself. Okay, so in other words, if 4/9 of the students are boys and there's 36 in the class, that means 16 are boys. So here's the class at 36. We have 16 boys, and by default, that means there's 20 girls. 16 plus 20 is 36. We're told that 2 girls drop and 4 boys drop. So our new numbers are 18 and 12. Okay, so this is after the drop week. In other words, there are now a total of 18 plus 12 are 30 students in the class, 18 of whom are girls and 12 of whom are boys. The question is what percentage of the class is girls? That would be 18 over 30. We can see that the answer choice is written as a percentage, not as a fraction. So we have to reduce this. Again, I recognize that 18 and 30 are both common factors of 6. 18 divided by 6 is 3. 30 divided by 6 is 5. Again, that just helped me reduce the fraction. Now I got to convert the fraction to a percentage by doing log division, namely 3 divided by 5. Now we ask ourselves, how many times does 5 go into 3? It doesn't. We have to add the 0. By adding that 0, we have to bring up this decimal. 5 goes into 30 6 times without going over. 5 times 6 is 30, so there's no remainder. 0.6 is the same as 60%, which is our answer choice. Okay, so again, this problem made something that would otherwise be very straightforward a little more challenging, because we went from boys, which were 16 of them, to girls, which required you to subtract and find the new total, as well as convert a fraction to a percent to get this answer. So again, in this practice test, there are no give-me's. Nothing's too straightforward. You have to work for it, and you should feel that way on the ASVAB. Right, number 11 says, after leaving the Air Force, John is looking for a job in the private sector. He's decided the only salary with which he'll be satisfied must be within $500 of $5,500. Which of the following inequalities can be used to describe his salary requirements? Let S represent the salary he's offered. Okay? So in general, the way I think of this one is the difference between the salary he's offered, which is going to be this, the salary he's offered minus 55,000 must be less than or equal to 500. Okay? And that's just taking this problem and transcribing it into a absolute value inequality. And if you think about it, let's plug in some numbers and see if this works. Let's say he's offered $55,001. Oh, I made a mistake there. $55,001. So that would be 55,001. We're asking ourselves, is that less than or equal to 500? 55,001 minus 55,000 is just 1. The absolute value of 1 is 1. So 1 is less than or equal to 500. Okay? Let's say he's offered a salary of $49,999. Okay? Again, oh, not 4. My bad there. Let me rephrase that. Let's say he's offered a salary of $54,999, and that's going to be, let me get rid of this because we saw that that worked. Let's say he's offered a salary of $54,999. Again, that has to be within 500 of his expected salary of 55,000. So let's plug this into the equation I wrote and see if it works. 54,999 minus 55,000 is just 1, or negative 1. The absolute value of negative 1 is just 1. And we can see that 1 is less than 500, so this works. This is the only equation into which you can plug these numbers and come up with the true statement. So you have to be able to convert a word problem into an equation using absolute values, which I did right there. I didn't do it well, but I did show you the concept. So again, you have to get good at transcribing conditional problems like that into equations. And the best way to do it is to plug real numbers in and see if it meets the requirements of the question. Alright, number 12. A product originally cost $125. If the product goes on sale for 20% off, then goes on sale for an additional 30% off, what is the price of the product? So I'm going to talk you through doing this problem without working it out, and then we'll work it out. So again, this one had two different sale prices. So I'm going to call this one sale price 1. And we can find that by taking the original price minus 0.2, or 20%, times the original price. This says sale price 1 is equal to the original price minus 20% of the original price, the 20% discount. Okay? Then we're told that there's an additional 30% off. So I'm going to call this sale price 2. That's going to be sale price 1 minus 0.3, which is 30%, times sale price 1. Okay? And this will tell us what the final sale price of the product was. Okay, so we have to do these two things to get the right answer. So let's go ahead and work on that. Again, let's start with number 1, and I'll label it 1 down here. Again, I'll call this sale price 1. Original price is 125 minus 0.2 times 125. I'm Let me go ahead and work that off to the side. 125 times 0.2. Again, we're doing a whole number by a decimal. So I have to shift this decimal place one time. In reality, I'm doing 125 times 2, albeit with one decimal to shift back in. 5 times 2 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 1 is just 2. So we're going to add our decimal back in. So this is the same as 125 minus, again, that's 0.2 times 125 is 25. Sale price 1 equals 125 minus 25, which is just 100. Okay? So now we got to figure out what sale price 2 is going to be, which is the additional discount. And that's sale price 1, which is 100, minus 0.3 times sale price 1, which is 100. Should be able to do this one in our head. 100 minus 0.3 times 100 is 30. So 100 minus 30 is 70, which is right there. Again, if you can write this out and work through the problem logically, the math becomes very simple. Again, sale price 1, original price minus the discount. Sale price 2 is sale price 1 minus the discount on the sale price 1. So that's that one. Again, nothing easy in this practice test, so don't beat yourself up if it was too difficult. 13 says a maintenance worker is asked to paint the ceiling and walls of a room. The room is 10 feet wide, 15 feet long, 10 feet high. The gallon of paint covers 175 square feet. How many gallons of paint must he purchase to complete the job? So, again, large part of math is being able to see things visually. And the higher you go, the better you have to be at visualization. Okay? So this is our room that the maintenance worker has to paint. We're told that it's 15 feet long, which is right there. It's 10 feet tall, which is right there. And it is 10 feet wide, which is right there. Okay, so it's a rectangular room. He has to paint the ceiling and the walls of the room, so we're not painting the floor, which is right there. So this problem requires you to understand how to calculate surface area, albeit for only 5 of the 6 faces of the room. Again, let's think about this. We have a ceiling, which is right here, and a floor, which is right here. There's 2 faces per side. There's a ceiling, a floor, a width, and a front and a back. So there's 6 faces for all rectangular prisms, and we're only painting 5 of those. So the ceiling is just going to be 1. And we can see that the ceiling is the same as the floor, which is 15 feet long by 10 feet wide. So this is the ceiling, which I'm going to call C. That's going to be an area. And again, area for rectangle is always length times width. That's going to be 15 times 10. Okay, that's the ceiling. We're not doing the floor, otherwise that would be 2. The side wall, which is kind of like right here in this picture. Let's think of it right here. Again, the room's 10 feet tall, so this is the height of the room. This is the width of the room. So we know, let's call this the side wall of the room. Again, there's one here and one here. So we know there's going to be 2 of them. But the area of one of the side walls is 10 times 10. And again, there's going to be 2 side walls, so we're going to have to double this. Okay? And then let's call this the long walls. Those look like this. This is the face you see. This is the long wall. Again, there's two of them. The room is 15 feet long by 10 feet high. So to find the area of that, we're going to do 10 times 15. And again, there's a front. If I were to just sketch this out like a skeleton with no other rooms, there's a front long wall and a back long wall. So we're going to have to multiply this by 2 as well. Again, the ceiling's not being multiplied by 2 because there is no corresponding floor. So let's work this out. 10 times 15 is 150. 10 times 10 is 100, times 2 is 200. And 10 times 15 is 150, times 2 is 300. Let's add these all together. 200, 300, 150. 0 plus 0 plus 0 is 0. 0 plus 0, 0 plus 0 plus 5 is 5. 2 plus 3 is 5, plus 1 is 6. So we can see that he has to paint, the maintenance work has to paint 650 square feet of walls and ceilings. Okay? Now the question is this. 650 divided by 175 equals how many buckets of paint? Okay? Again, we know that one bucket covers, or 1 gallon covers 175 square feet. The painter has 650 square feet to do. So in other words, he needs more paint than there are square feet on the walls. There's a couple ways you can think about this one. You can do 175. This is 1 gallon. Again, this is your gallons. This is your square feet. 175 plus 175 is, again, this would be 2 gallons, 3 gallons, and 4 gallons. To find how many square feet 2 gallons covers, let's do 175 plus 175, or we can do 175 times 2, which is a little bit easier. Five times 2 is 10, carry the 1. 7 times 2 is 14, plus 1 is 15, carry the 1. 2 times 1 is 2, plus 1 is 3. So this is 350 square feet that 2 gallons of paint covers. To figure out how many square feet 3 gallons of paint covers, 175 times 3. 5 times 3 is 15, carry the 1. 7 times 3, 21, 22, carry the 1. 3 times 1 is 3, plus 1 is 4. So 3 gallons of paint covers 425 square feet. Let's do 175 times 4. 5 times 4 is 20, carry the 2. 7 times 4 is 28, 29, 30, carry the 3. 4 times 1 is 4, plus 3 is 7. So 4 gallons of paint covers 700 square feet. Again, we have to paint, or the maintenance worker has to paint 650 square feet. So if he uses 1 gallon, he's too short. 2 gallons, too short. 3 gallons, he's only going to be able to cover 425 square feet. If he uses 4 gallons, however, he can cover 700 square feet, which gives him 50 extra square feet of paint. So we know he needs a minimum of 4 gallons of paint. Okay, so that was that one. Again, you have to be good with visualization to do those problems. Okay, number 14 says during the school year, each student planted 2 times 10 squared trees as part of the community service project. If there are 3.5 times 10 to the third students in the school, how many trees did they plant total? So we know that number of students is 2 times 10 squared. We should be able to see that 10 squared is 100, so 2 times 100 means there are 200 students. And this is going to be, this is number of trees that each student planted. This is going to be total students. And we're told that there are 3.5 times 10 to the third number of students. Let me go ahead and work this out down here so you can see it. 10 to the third is 1,000, so this is 3.5 times 1,000. Whenever you multiply a decimal by a 10, 100,000, and so on, you simply shift the decimal according to how many zeros there are in that number. In 1,000, there are 3 zeros, so I'm going to shift this 3.5, 1, 2, 3 times, so I know there are 3,500 students at the school. So again, each student planted 200 trees. There are 3,500 students. So to find out how many total trees were planted, we're going to do 3,500 times 200. And that will tell us how many trees all the students planted combined. 0 times 0 is 0, 0 times 0 is 0, 0 times 5 is 0, 0 times 3 is 0. We're starting this number, so we have to drop down a 0 before we begin. 0 times 0 is 0, 0 times 0 is 0, 0 times 5 is 0, 0 times 3 is 0. Starting this number, so we have to drop down 2 zeros before we begin. 2 times 0 is 0, 2 times 0 is 0, 2 times 5 is 10, so we got to carry the 1. 2 times 3 is 6, plus 1 is 7. Let's add 0 plus 0 plus 0 is 0, 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 0 plus 0 is 0, 7 plus nothing is 7. Add our decimal every 3, 1, 2, 3. We can see that this is 700,000 trees. Not a very easy problem to do, but once you realize what's going on, it's not too difficult. Okay, so let me go ahead and work this one out for you. It says 15 boat builders use 15 says boat builders use an old rule of thumb while constructing sailboats. The maximum speed k in knots is 1.35 times the square root of the length L in feet of the boat's waterline. A customer is planning to order a sailboat with a maximum speed of 8 knots. How long should its waterline be? So again, we have to be able to convert this formula. We have to be able to convert this word problem to a formula. K equals 1.35 times the square root of the length L. Okay? And then this becomes a pretty easy problem to work on. Again, we're solving for L. We're asked how long should the waterline be. So the first thing I'm going to do is divide both sides by 1.35. Oh, wait a second there. We're told how many knots they want. They want a maximum speed of 8 knots. So instead of K, we can put 8. That's told right there. Okay, so again, we're going to divide both sides by 1.35. This crosses out. We're left with the square root of L equals 8 divided by 1.35. Okay. So now I have to figure out what 8 divided by 1.35 is. And let's go ahead and do that. Again, we can do long division with decimals as long as the decimals are inside the division bracket. Since they're outside the division bracket, we have to shift this 1 2 times. The decimal's technically right here, so we have to shift that 2 times as well. So this is 135 into 800. Okay. And now the question is, how many times does 135 go into 800? I'm going to take a guess and say it's going to be about 5 times. Again, I'm trying to get 135 into 800 without going over. So 135 times 5. 5 times 5 is 25. Carry the 2. 3 times 5 is 15, 16, 17. Carry the 1. 5 times 1 is 5, plus 1 is 6. Okay? If I were to do 135 times 6, let's go ahead and see what that would give us. 6 times 5 is 30, carry the 3. 6 times 3 is 18, 19, 20, 21, carry the 2. 6 times 1 is 6, plus 2 is 8. You can see that this would put us over this 800. So in other words, 135 goes into 800 times, 800 5 times without going over. 5 times 135 is 675. Subtract. We can't take away 5 from nothing. We can't take away 7 from nothing, so I have to borrow. This becomes 7. This becomes 10. This becomes 9. This becomes 10. So this is 5, 2, 1. Okay, now the question is, how many times does 135 go into 125? It doesn't. 135 is bigger than 125, so I have to add a 0. When I add that 0, I have to add a decimal place up there. And now I'm asking myself, how many times does 135 go into 1250 without going over? And I'm going to say that's going to be not 10 times, because that would probably 135 times 10. Again, remember what I told you. When you multiply it by 10, 100, or 1,000, you take this decimal and you shift it 1. So 135 times 10 would be 1350, which is too big. So I know this is going to be 9. Okay? And to do this problem, you have to be comfortable saying, you know what? I'm just going to estimate this as 5.9. Whichever of these answer choices is the closest, I'm going to go with that. So again, square root of L equals 5.9. And now we got to get rid of this square root. To do that, we're going to take the square of both sides. This crosses the square out. We're left with L equals 5.9 squared. And now we actually have to work that out. And again, we're doing 5.9 times 5.9. That is, we're doing a decimal times a decimal. I'm going to shift this decimal 1 time to make 5.959. Shift this decimal 1 time to make 5.559. So in reality, I'm working this problem out as 59 times 59, albeit with 2 decimals to shift back in at the end. Okay. 9 times 9 is 81. Carry the 8. 9 times 5 is 45. 40 plus 8 is going to be, what is that? 45 plus 8, 53. Okay. Add a 0 since we're starting with this number. 5 times 9 is 45. Carry the 4. 5 times 5 is 25, plus 4 is 29. 1 plus 0 is 1. 3 plus 5 is 8. 5 plus 9 is 14. Carry the 1. Again, that's a 4. Sorry about that. 2 plus 1 is 3. Add our 2 decimals in. 1, 2. Just by rounding, I get 3481. 3481 gets me close to 35. It's much closer than that. It's much closer than that. It's much closer than that. So by estimating this, I'm confident in saying that 34.81. If I were to add all these decimals by doing a lot of long division, would have got me 35.1. So I'm content with that one. Sometimes the math gets too tedious on the ASVAB. I experienced that when I took it. You just have to be comfortable estimating some of the answer choices. Okay, number 16 says, at the county fair, James sold the following pieces of artwork: a sculpture for $80, an oil painting for $168, an ink drawing for $52, and a photograph for $52. What was the average price of the pieces of artwork he sold? So again, we're looking for the average, so that's going to be this. Average equals the individual items, 80 plus 168 plus 52 plus 52 over how many items there are. There's 1, 2, 3, 4. Okay, so let's go ahead and do this addition off to the side. 68, 52, 52, and 80. 2 plus 2, 8 plus 2 is 10, plus 2 is 12. Carry the 1. 5 plus 5 is 10, plus 7 is 17. 17 plus 8 is 17, 18, 19, 20, 21, 22, 23, 24, 25. Carry the 2. 2 plus 1 is 3. So this average is going to be 352 divided by 4. Again, we have to regard this as division. 352 divided by 4. 4 does not go into 3. 4 goes into 35 8 times without going over. 4 times 8 is 32. 5 minus 2 is 3. 3 minus 3 is nothing. Drop down this 2. 4 goes into 32 8 times without going over. 8 times 4 is 32. So there's no remainder. So we can see that the average price for the artwork that he sold was $88. So that's this practice test. Again, fairly challenging. Again, I can't create practice tests that are all easy. My idea is to expose you to easy questions and hard questions, and if you watch all my videos and take all the practice tests, you'll know more or less, how to approach each problem, which should help you score pretty high. So that's it for this video. I'll be posting the other videos pretty soon.